to rotate. And this you can just constantly spin. And then the last button is grip lock. So
And that's on the left.
Yeah, over here. So grip lock's on the left. So if I close, I hit grip lock, then I can let go of that. I can also re-index and it'll stay. Now, the problem is that if you don't have grip lock and you re-index, so I can go ahead and close this, index, without grip lock, if I let go of this and I'm not holding down the trigger, it's going to open. It's standard that somebody who's learning loses at least one sample. You know, it's just like, you know, and you... Now there's, if you've forgotten, you have little things like, you can close, have it indexed, oh I forgot, well I can hit the trigger again, do that, right? But if, unless it changed in the software update, you can't do that. I did, nice. I love updates. Yeah, so the main button is the top button and that's your index button. And let's see, I think force feedback is on. We're going to see. Not really. So force feedback, we're not really running force feedback right now. We won't. Force feedback is its own finicky. So right now the camera's racked back, so it would be very difficult to reach out that way, but we'll basically kind of keep the arm outside of the frame of the vehicle instead of coming in at all. We'll just stay over in this range. Pass that over to you.
All right.
So, and before you unindex anything, just kind of feel how it feels to move it around. Yeah, it's a two-hand operation.
And so the arm is kind of like this right now.
The arm is, you're right for the shoulder, except to get it accurate for here, you'd have that, but then these are down, right? You know, so that would be a pretty good mimic of where the arm is right now.
Oh, yeah, because this is the second, that's that joint.
So if you hit the index button, and then just move this out. Everybody has different goals in life. Well, I don't get to use the stick of pointing very frequently. I mean, I understand the... Okay.
So this joint doesn't have a lot of motion. Is that where it stops?
Which one?
The
wrist pitch or the elbow? The elbow's fully up now, but then it'll come all the way back down to, yeah. So it's as far up as it goes.
So yeah, it'll come back in here. Got it. And this is wild. It seems like one of the hardest things to do would be to like re-index if you get yourself into a wacky configuration.
Yeah, sometimes figuring out how to get out of a weird configuration.
So this is kind of, I guess you would leave the wrist down. Like this is kind of where you stow it a little bit.
Your shoulder's still forward, and part of it, you end up learning how to use the lights and the shadows.
That seems like one of the other tricky things is, you know, everything kind of looked two-dimensional in the wrong light.
Everything looks it's hard to get depth perception. What? Yep.
We have another question. They would like to know, have artists ever joined the expedition? Aaron, I kind of think of you as an artist. You have an eye.
So why doesn't this?
They have
Which one?
artists that do come
Or
on.
do you have to?
So you have to tap that. If that light's on, then.
Oh, got it.
Yes, we've had an Artist at Sea program before. It's kind of now more integrated in with the Science Communication Fellows. So they'll come out as an SCF. But yeah, we've had people whose art is in different mediums, so like oil painting, acrylic, watercolor.
So now
some
if I
illustrators,
lock the jaw, which is on the left.
Yep.
Multi-media
yeah, you can let go and the
art.
jaw will stay closed.
But now I have to re-trigger before I release it.
No, you can leave the jaw locked, and you can have this released. You can hit the index button, and the jaw will stay locked.
And now if I hit this again?
It'll stay closed.
Got it.
So if that light's on, the jaw will stay in whatever position it's in. Or to be more accurate, the jaw will continue sending whatever signal it was previously sending. So if you think you're holding it partially open, you're likely not. You're likely sending some little signal in one direction or another, and so you will end up closing all the way. And so like when I did that soft coral grab, I didn't re-index once on the way in, because if I did, it would likely end up crushing it.
Got it.
To the artist who would love to come and compose music live for the stream one day, you should apply on nautiluslive.org. Well, they'll give you some information on how you can become a part of the team.
So then when you're feeling like you want to go for it, we'll try and grab the hockey puck that's holding the slurp.
Okay, can I adjust the bubble cam to get another?
It actually is time too for people to start applying for internships.
Let me know if I'm just getting close to anything that I should do.
It's time for the people to start applying for internships. The application's open right now.
Oh, that's awesome. These are definitely opportunities I wish I had when I was younger. So all of you young folks out there, this is a great opportunity to learn and prepare yourselves for the future in whatever occupation you have in STEM. So look out for those internships that are also on nautilus.org.
So where would you have the...
Usually I kind of try to come in and I'll bring the pincers in on the top and kind of grab it from either side.
As far as the
you can even, if you take your pincers like underneath the hockey puck,
check the website.
The big ones go underneath the hockey puck, the little ones go on top. You could probably get a good grab that way too.
It's not the best grab, but.
Yeah, but it's your first grab. And you can always let go and give it a regrip, or?
Oh, because it's not spring loaded or anything. So now
it'll slide back a little bit.
Oh.
But sometimes, yeah, it's like if it wants to spin, it'll be useful to help get a better grip on something.
And then you'll shake it out here.
So that tube is another part of Hercules that can be used to suck up samples that are on the seafloor.
Oh, all right, so go ahead and open. Yeah. And then you might want to, what I would do here is I'd probably close the jaw and just kind of like reach down and kind of nudge it back in.
Yeah, let me just re-index for a second.
Sure.
And kind of. Oh.
Yep, you got the right idea. And you can go all the way down to the end of the suction tip and get a hook in there, or, you know, nudge on that to help move it in. There you go. Nice.
You guys make it look easy.
Now watch your top, because one of the things that is hard here is that you do have that sealing, right?
Is that something you have to watch out for?
You can take every light off of the light bar.
Okay.
Yeah.
And is that the kind of thing that as an Argus pilot gets further along, like they'll kind of keep track of where things are and help you with that?
Yeah, keep track of things, and then you reach a point where, you know, I can fly and you can take the sample, you know, that kind of thing. All right, rotate out a little bit more. Yeah, there you go. So we'll stay on that side, because you can, there's all the little, you know, like you can end up getting the hockey puck kind of wedged inside of the frame. If you end up, there's always tons of ways to get stuck. It's amazing, actually.
Yeah. But when you reach an end stop, like if this wrist at its end, are you, like, you're not damaging anything? It can touch itself?
Yeah.
Without, yeah.
Go ahead and bring your shoulder up a little bit. Yeah, there you go. Just a happier position. When it's all the way down, then you're just a little bit of tension on the cables. So yeah, you can see you can get into almost any position, but you can also get stuck in a lot of positions.
Yeah. Can I try for the hockey puck again?
Sure.
Me? Yeah, but it is off. But let me turn it on for yeah. Cool, thank you. It's not too far of a stretch.
What are we, like 240 meters away?
240 meters away.
From the ship, 207.
Yeah, just the layback of the vehicles.
The vehicles are 200 meters behind the ship.
Because we've been dragging them. in a not trawling fashion. Midwater trawl.
Cool.
Are we in a trolling fashion?
Troll doll.
Troll doll.
All right. Oh, but we are, as far as how far away are we from the target?
Yeah.
We are 4,100 meters away. But we sped up a bit, so it's only about an hour and 15 minutes.
Okay.
So we're gonna approach it. Just before we get there, there's a bit of flatter terrain. We'll kind of reacquire the bottom there, get all set up, and drive up to
Actually,
our
here's a
target.
good idea. Go ahead and index it.
Yeah?
I'll go ahead and I'll grab it, pull it out, put it back, and then we'll see if get you to go to mimic it. Give you a different, because sometimes figuring something out versus trying to mimic, and in this case, a lot of times the mimicking is the where best place to start.
Cool.
From
And
a
then
learning
Go ahead.
do you always lay it down?
Yeah, it's just safer.
Yeah.
It's a little cradle.
It'll come back.
Yeah, I find that actually, I don't think about this, but I usually come up over the end of the nozzle.
Mm.
What depth is the next waypoint?
It's around 500 meters.
500 meters.
So we've actually brought the vehicles up. We were at a much deeper depth, but since we're going upslope, we had to bring the vehicles up in the water column quite a bit.
Here's the
so
trick
we're
about
not,
all this. Do you see what I've
dragging
just
it on
done?
the bottom.
All right.
You've kind of gone
So
on
the vehicles are already around 500 meters. So
metal piece.
Aaron, Aaron, you want to zoom in?
You've gone below the hockey puck.
Hold that. I'm underneath the hose clamp.
Oh.
Oh.
So all of this involves paying attention to the tiniest little thing.
Wow.
Would have ripped that thing right out.
Right. And then you have a problem, right?
Right. Smash that hose
Okay.
clamp down.
Can we zoom back out?
Sure.
So you take the shoulder, straight up. What are...
When the shoulder's straight up, well, go ahead and finish your question.
Yeah, I guess what am I worried, like, when do I get worried about the lights?
You don't get worried about the lights when the shoulder's straight up. You can go up to about there. And that's just the elbow, but it's dark in that corner.
Mm-hmm.
But that's your elbow is what you're actually worried about. If I wrist it up at this point, yeah, it hit lights.
Got it.
But that's pretty high up away from where you're going to be operating.
So you have to take the elbow and the wrist basically up.
Yeah, because you can go up high enough on the elbow to hit the foam pack, but it's only with the wrist and the elbow up that you can wipe everything off of there.
Okay.
So I'm going to put you in a usual stow position and then
Weird question too, but can we swap the monitors? Is that...
yeah, we can do that. Actually, let's see, what are we doing? Why don't you sit here?
Oh, okay.
That way you have the armrests.
There was a fish. So are we at Point Arena or are we headed there?
So the area is actually called Point Arena South. It's an essential fish habitat conservation area designated by the Pacific Fisheries Management Council. And Point Arena is actually northeast of our area.
Okay.
So we're kind of at the Sonoma County, Mendocino County border. And Point Arena is in the southern Mendocino County area.
I see. Some of you may notice that the RV arms is being manipulated with the hose, and that hose is used to suck up specimens and samples that are on the ocean floor. And we have an ROV intern on board, and he has an awesome leader showing him how it all works. So that is the purpose of the hose. What I love most about this expedition is that they bring science interns, and they allow ROV interns to come over here and learn real life skills. And so soon these people will be navigating their own ROVs in the future. Pretty cool. Keep in mind that if you aspire to do any of these things that are happening on EV Nautilus, you should check out the website and look at what internships they have available to you. So some of the goals for this dive is exploration and characterization of Point Arena South. They're trying to identify areas for future research of deep sea corals and sponge habitats that will serve as sentinel sites for ocean acidification and monitoring and identifying impacts within an upwelling region. Anyone want to share what was for dinner on Nautilus? Someone wants to know, what did we eat? What do we have for dinner? Nobody? You want to say? I think they had we had like 4 different varieties of salads and some delicious looking shrimp.
Greg Greg listed off his private menu of.
They want to know, what are we eating? They feed us well, I can tell you that.
I tried to be healthy.
Yeah. It was.
There's always a nice variety of different salads and different veggies. Sometimes they're grilled. Oh, there was some awesome peppers, and yeah, a different variety of peppers that were kind of, I guess maybe, were they broiled?
They look like sauteed.
I don't want to say they were sauteed. Yeah, they were sauteed.
Why don't we tell the audience, how did you get into your career? And why don't we start from the back row with the scientists? Can you share how you got in your career?
I've had lots and lots of different jobs. When I was in school, my initial major was ceramics. And I realized, oh, I have to run my own business if I'm going to ever make a living being, a ceramicist. So I decided pretty quickly that that was not going to be possible. And through the general ed courses that were requirements, I took a biology course. And I'm like, I think I'm actually pretty good at this. So then I went on from there. And yeah, my mom was always interested in science, even though she never really graduated from high school. She loved the space program. And we would watch the moon landings and always watch the takeoff of the spaceships and what have you.
That was good. I did not know you started in ceramics.
All right, who's next up willing to share? How did you get into this profession?
I think the key for me was good inspirational science teachers in high school. And the biology teacher took us to the tide pools at low tide along the Pacific coast, and that's got me started right there in marine biology. The field trips to the coast, and a good science teacher.
Awesome. Who's next?
So, I've always been interested in science, but I wasn't sure exactly what aspect of science I was interested in going into. So, during college, I did a number of internships in a diverse array of fields, and I double majored in biology and neuroscience because I wasn't sure which one I was more interested in. And after I graduated, I did some research in a lab that was more neuroscience focused and decided that wasn't quite what I was looking for. I wanted something with a field aspect instead of only lab aspects. And I had always been interested in marine biology, but thought it was an impractical career. So I hadn't considered it too seriously, but after doing something that I didn't enjoy very much, I decided to go for what actually interested me. And so I applied to grad school in deep sea research field, and that led me to Nautilus.
Awesome. Who's next?
I'll go. This is Renato. I probably would start with my master's work, but in the back row when you guys were talking about earlier stuff, that kind of was inspiring me to think back. And I remember when I was in 6th grade, something like that, we had a science teacher who was really great and very hands-on, Mr. Fiedler. And he also allowed some of the quote-unquote indoor kids to, instead of going out to recess, you could stay inside and build things out of Kinects and other.
Awesome.
Like, so we built those big giant roller coasters, all that stuff. I was definitely like, a nerd. But I didn't really follow the science.
That sounds awesome.
Yeah, it was great. I didn't have to go outside and play.
They gave you that option. That is wonderful.
Yeah, and I think back to it and I'm like, this guy, he was just on his lunch break. He didn't have to allow all these kids running around his office while he's sitting there. But I thought that was nice. And but yeah, I didn't really pursue science until later on in college, and I didn't really start doing field work or geospatial technical stuff, remote sensing and all, until grad school. And there I was doing more land-based remote sensing and working on glaciers and in the cryosphere up in the Arctic. And then I was down in the high Andes working on rock glaciers. And then from there I got an internship on Nautilus using what I knew from LiDAR, and which was what I was working on in my master's at University of Delaware, and then translated that into multi-beam sonar, which is what I work with on the ship, and then through seafloor mapping I got involved in some of the ROV operation stuff, and now it's kind of more half of my career is science operations and the other half is seafloor mapping. So
Awesome.
Greg.
Can you repeat the question?
Tell us how you got into this profession.
Let's see. I would say that as a kid, I always liked to try and take things apart with the intent of figuring out how they worked and then putting them back together. Most of that was just taking them apart.
Yeah, I did that with light up shoes when I was a kid.
A lot of them
My mom
did
was
not
so
go back
pissed.
together.
I was like, well, look, this is the thing that lights up. She's like, great. What are you, your shoes are just torn apart. Well, I have the blinky thing, so.
Yeah, so I'm happy.
Yeah.
And then I too had a high school teacher who was, I guess, a big inspiration. He ran the first robotics team for the high school, and we competed nationally. We had a funder that paid the admission fees and gave us a place to design and build these robots for the competition. And that was just him volunteering his time, but for 6 weeks out of the year, if we weren't at school, we pretty much lived at the warehouse that the robot was being built in. And he was right there with us. And then for all of the trips and everything else. And so I did that for 4 years, and just knew that I was going to be a mechanical engineer, and went to Eckerd College to do a 3-2 program. So after 5 years, you'd graduate with a liberal arts degree and engineering degree, and got lost. Switched to physics and math. Dropped physics or dropped math after I got to partial differential equations.
Yikes.
Yeah, those are hard.
Yeah.
And picked up computer science because I was always good at it, but it wasn't really my favorite subject. And so graduated with that. My senior project was a 6-legged autonomous walker with edge sensing and ultrasound.
Wow.
And then I had a friend send me a link for an internship, which was the MATE internship. And I applied for that. Got it. Got sent to Harbor Branch Oceanographic Institute to work on the Seward Johnson as a marine tech. I turned that into a full-time job for a couple of years. Met enough people, started contracting with AUVs, and then came out here and started contracting with ROVs.
Nice.
All right, now I feel like I'm a slacker.
Feel free to add some more.
This is the Greg show. Sorry, the bridge is just calling me. It's unrelated.
Yeah. It's okay to be jealous, George. It's fine.
Oh, man. People always ask, they write in and they ask how to become an ROV pilot, and I think there's a lot of unconventional ways that people get into that profession.
Yeah, one of the best ones is through an internship.
Yeah.
A lot of it, though, really comes down to impressing people, I guess. Some of the, I think the best compliment I ever got was from a boss was, it doesn't matter what task I tell you to do, you do it.
Right.
It's like,
Yeah, you really just have to do the job well. You got to perform well. And you could have glowing, background or something like that. If you come out and you're not working hard, then you're not going to get asked back. And that's kind of true for anything, really. I think just work hard and show that you're eager to do, the work.
Right, because even if you get out here because of an internship, you get invited back because...
What is that little thing?
It's a little squid.
Is it? Oh, part of a squid?
No, it was a whole squid.
Was it?
Yeah.
Yeah, that's a little squid.
Oh.
Youngin.
But you get asked back if people like working with you.
Yeah. That's another dimension about working at sea, I think, that is often overlooked, is you could come out here and be the best at your job, but if no one likes working with you, that in tandem with that, it's
We're all in the
we're all
same
living.
boat.
Yeah, we're all living out here. So if they don't like working with you, or if you're not really easy to live with, then that's kind of, you're not going to last too long. So you have to, yeah, make sure that you're. You know, that there's a surprising amount of people who do this very often that they also get seasick, and I thought if that was
I
me,
feel
I
it's
would
becoming
just
the Rennie show.
I would just stop. I would just stop coming out. Back to you, Greg.
I was telling George that. Actually, it's Paul's turn.
Yeah, Paul.
Is that how I got here was the question?
Yep.
So similarly, it probably started in high school. I thought I was going to be a history major, and nothing against history majors. But I had an awesome physics teacher who also ran our school engineering club. Okay. And so we competed in kind of science Olympiads, and that shifted me towards engineering in college. I knew I liked to build stuff and to do mechanical design. And for me, it kind of really all clicked once I had my first controls class, and I realized, oh, this is the kind of math that I like to do along with design. And controls can be used for a lot of different things, like energy management, power systems, stuff like that. But for me, it went with robotics. So I had started a volunteer kind of program in a research lab. And through there, I met one of my he ended up becoming one of my good friends. He was doing his PhD program through the NASA Space Technology Research Fellowship, and he managed to connect me with a lab up at NASA Ames. And once I started doing kind of space robotics, it all...
Yeah, there's no turning back from that.
Yeah, I was sold. So after that, I applied for my PhD program and stayed at UC San Diego. After my first year, I kind of started out as a master's student, TA'd my way through my first year, and my second year I managed to get a full year internship at JPL.
Nice.
And during that time, I applied for the same fellowship that kind of this friend had and told me about. And that then I was accepted to that program, and that's basically got me through the rest of my PhD so far.
How many years in are you?
So this is the beginning of my 5th year.
Okay. So you should be, and you didn't have a master's going in.
Yeah.
Is that correct? So it's like 6-year time frame or something?
Yeah. So it'll be about another year and a half. So
yeah.
about 6.5.
Cool.
But I definitely took my time with it because I wanted to get a lot of hands-on experience, you know, so that year internship was very transformative. Doing experiences like this, it really kind of connects a lot of dots, and I think is invaluable. So that hands-on practical experience and being willing to jump at whatever opportunities you kind of find yourself with is really valuable.
Yeah, absolutely. Being opportunistic is super critical. It may not be like, some people they have a very fixed focus goal and they only want to get there via this one particular path, but you can pass up so many opportunities along the way by doing that may contribute to you getting out to your goal, or may shift your goal because you don't know what you don't know yet, you know.
Yeah, I was going to be a professional soccer player. If you asked middle school me, that was the only thing.
There's still time, Greg.
Yeah.
Yeah.
Nice.
But then robotics, and it just kind of went from there. You never know what your path you're going to end up taking. So it's more about not shutting doors.
Right.
Aaron.
Hello, I'm Aaron, the video engineer.
Aaron's about to show us all up right now with this.
So my path is probably the least traditional path. I started in wildlife ecology and natural resources at Washington State University. I originally was going there to be a vet. Realized I actually hated being inside a lot. Switched to wildlife ecology, graduated, went immediately after I graduated to an internship, not an internship, I was a field technician in Madagascar using remote cameras to study lemur population dynamics.
As you do, casually.
I picked up a camera and I guess I became obsessed with it. Found a program in England that worked with the BBC, and so I got my master's in wildlife documentary production over there. Immediately met my mentor, my camera mentor, who specializes in brown bears and underwater alligator filming. So I started
underwater alligator filming.
So
that's totally different than above water alligator.
Yeah, because you're in there.
Yeah.
You're in there with it.
And so he's done quite a bit for National Geographic. So he was kind of the person that gave me my first chance. And he's like family to me still. I'm forever grateful for him. But I interned with him, ended up on a boat my first year assisting him on a shoot for the Smithsonian, filming brown bears. So we lived on the boat and with 2 other people and went to shore every day and filmed bears. And then I heard about this internship, ended up getting an internship here as well, and just kept filming and eventually moved from assistant to full-time camerawoman on wildlife shoots for documentaries, and just kept coming back here. They seemed to be okay with me coming back. So, and I ended up buying a cinema camera quite early on because I also run a commercial fishing operation in Alaska, and I used that money, I saved it up to buy a camera and just kind of did it.
There's another casual drop there. You
Yeah.
see.
I think she's trying to get work through this introduction here. Why don't you tell everyone what's coming out that you got your...
I can't, actually.
Oh,
Wait, which one?
No, the one that you just posted.
Oh, so I just worked on a big shoot, and it's my first time having David Attenborough narrate my footage, so I'm pretty excited. It's just a few shots, but
beautiful
exciting.
shots.
That's awesome.
Yeah.
That is pretty cool.
Yep. So yeah, but I did all sorts of jobs. I did everything from guiding and being an office person for an adventure lodge to being on a sailing crew down to the sub-Antarctic. So I'm definitely agreeing that if there's opportunities, kind of look in them and see if there's something in them that will help you, or if maybe it's a person, even like a mentor that you can learn from, and that information and that knowledge is invaluable. So you never know what you can get from things.
Right.
Yeah, I took 0 oceanography courses. Some were cross-listed, but I didn't have an oceanography background, and now I'm doing ocean work because of an internship.
The internship's amazing, and it's open right now, like we've been saying, so I would completely recommend it.
Yeah.
Absolutely.
I'll take a page out of Ed's book and mention that...
Flamboyant squidworm. Galapagos.
Yep. If you don't think you should apply, or think that you're not, good enough or not what we're looking for any internship, really, just do it anyway. Because you never know. You never know what somebody's looking for.
In worst case, they can say no. That's not really that bad.
Right.
Right.
It doesn't take that much time to apply to as many things as you can. I had some people come up to me and say, "Oh, you do such cool stuff, like all this like field work and everything. Like, I wish I could do that." And I'm like, "Well, we get all the same emails." You know, like it's not that. You just got to really get in there and start applying.
Yeah, and even if you get in and you find out you don't like it, still you know now that I don't want to do that, which can be super helpful.
Yeah, someone I know is a really talented climate modeler, and she attempted to do some field work in some of the regions she was modeling, and she did not like that. Found that out very quickly, and now, so but she still did it.
I guess I can share a little something about myself. I've been teaching. This is my 13th year in education.
Stop a little bit before.
Yeah. I was inspired by someone named Sarah Milianta. She used to do STEM events for our whole campus, and I would see the eyes light up with all of the children and how engaged they were. And STEM was something new to me, and my son enjoys videography and all of that and making videos. So I just dived all the way in, all things STEM. And I became a science and technology specialist and the STEM coordinator. My principal wanted to be a STEM campus. And so I began to network with some of the middle school and high school people who are already involved in STEM. And from there on, I do project-based learning, problem-based learning with students. And what I love most about everyone's story is there was an educator that inspired you all, a coach of some sort. And so I'm that educator that's here to inspire children at as early as elementary, because it's possible, trying to catch them while they're young and let them know all is possible. And so I'm going to bring this experience back to my campus, and we'll do some problem-based learning in connection to what you all are doing. And that's about it.
That's really amazing. That's really cool.
Somebody would like to know, is the design of Hercules and Argus upgradable? Are there modular systems?
ROVs, these particular are custom made, and it's really just a bunch of parts put together. A bunch of sensors, a bunch of thrusters, manipulator arms, a syntactic foam, a frame. You can upgrade individual pieces over time. So, which has been done really since Herc was. The only thing that's original is the syntactic foam and the frame. Mongo's probably pretty original, the craft. The thrusters have been changed. Maybe some of the bottles.
Some of the thrusters are still the same.
Yeah.
The bottles are all the same.
Right.
Actually, the internals on Herc are pretty much the same.
When we say bottle, it's a titanium steel.
Argus is stainless. I think Herc is tie.
Yeah. Housing that holds some of the electronics that need to stay dry.
Can y'all elaborate a little more on the thrusters? How do they operate? What's their purpose?
Greg?
Can you repeat the question?
Thrusters. I know that Hercules has 6 thrusters, right?
Yep.
What is their purpose? How do they operate? What happens if there were no thrusters on Hercules?
That's a good way of putting it.
Well, I would say we would float, but if we're attached to Argus and Argus is sinking, we would not be floating. So the thrusters are all hydraulic driven. We have 2 horizontals, which we use for driving forward, backwards, turning left and right. We have 2 laterals for lateraling. And then we have 2 verts for going up and going down. The way that they're set up is that the verts you can't control individually, so you're either going up on both or down on both or nothing on both. And that's the same way for the lats. But the horizontals you can trigger individually. That allows you to turn left or right, change your heading.
Cool.
And yeah, I guess our worst case scenario, if something severed the tether between Herc and Argus, Herc would float. And we have a USBL transponder, which stands for, go Rennie? I don't want to steal your thunder.
Ultra short baseline acoustic positioning.
while we electrically trigger it when the vehicle is on, it can be acoustically triggered from the transponder on the ship. And so then we would be able to track the vehicle as it floated to the surface. And now we've had to do dead vehicle recoveries for either one reason or another when both Herc and Argus are being brought back up to the surface by the winch, but both vehicles are off, and we will track them and how they are relative to each other with those transponders.
I
So
think we should start
the no
seeing
thruster situation. Bottom soon?
Bottom soon, just to not freak everyone out.
I don't see anything.
And I'll do a reasonable amount away, a couple, maybe 100 meters or so on the flat bit. We'll stop. But not too close, not too far.
Sounds good.
Do we need to do numbers again?
Yeah, we should do numbers. Never hurts to do numbers.
Should I start a new page?
Yeah. There's either on the back or a brand new page. Are we out of pages? It's not the first time this has happened. All right, we'll continue on this page.
Cool.
And just make a notation that we're continuing. You're gonna want that back. Pine.
Jennifer Brown wants to say hello to everyone. She's going to be on Nautilus next week.
Awesome.
She would like to know how long are we planning for this dive?
I don't know, noon, 2 o'clock, something like that.
Yeah, so what's that, another 12 hours?
Another 12 hours, okay.
Plus.
14.
Yeah.